Tina, you want to start us off?
Sure. Hi, I would love to welcome everyone here. My name is Tina Ratterman, and I am the president of Big and Digital Film Distribution, and we are running the Cinema Learning Challenge program.
About your ticket, you stressed about your ticket.
Okay, we can start, guys.
So, yeah, and I would like to thank everyone for joining us who's on here today, all of the donors, everyone who's joining our event. Thank you so much for coming to our event today. This is our first virtual screening of In Saturn's Rings ever. So it's very exciting, but today it's really exciting because we're with the filmmakers. So we actually have the filmmakers with us that you're gonna get to hear from and talk to. So I just want to thank Sensore. She is running the event. So if there's any issues, write in our chat today and we'll try to address those with you. And then I just want to say it's an honor to be working with all of the filmmakers on this call today, and especially Steven Van Vuuren, the filmmaker that started this whole project. And I'm happy to be distributing this film since 2012 is when we started our working together. So this is very exciting, and I will turn it over to Steven Van Vuuren.
Hi, thanks, Tina. I appreciate that. Yes, welcome everybody. I just want to at the front say that this is a whole technical orchestra that's not quite in tune because we're all kind of clueless and trying to figure this all out. And if you're having any difficulties, right on the In Saturn's Ring website, insaturnsrings.com, if you click on news, there's instructions for how to run all this. And there's also a telephone number that you can text or call. Text is best, but if you need to call to get help with how that's been doing. So welcome to this streaming event, which is created by the necessity of the time. And I want to give a big thanks to Big and Digital for making this happen, because we didn't really have an easy option for doing live streaming that provided the kind of encryption and protection that we needed for this film. So we're very appreciative to them for building this infrastructure. And it's an honor for me to present the film and to have so many of the donors and volunteers here. Often in the media coverage, the film has been identified with me, but that's not the truth. I simply couldn't have done it on my own. I couldn't have done 5% of it on my own. So it's great to have these people here, and you're going to get to interact with all of these people very soon. The first thing I want to say is, yes, this is a streaming version of the film, and we got some questions from people saying, is it worth it watching on streaming? Because this is a film that was designed for the giant screen. And it's absolutely the truth that your experience of streaming this film will be nothing like seeing the film on an 8-story screen or in a full dome planetarium. And that is a completely different experience. But that doesn't mean that this experience doesn't have value. First of all, when you're a tiny little person, you know, let me see if I can do this on my phone. So if you're like barely that high in front of a screen, you often can't see the whole picture. So this is a chance to see all of that way. But the most important part of this live stream is the people that we have here for you to watch the film with. And it would have been impossible to gather all these people here together, to have them all in a panel because they're scattered all over the world. So it's really, view this as an insider's appetizer for the film. So don't view it as a replacement for seeing the film in a theater. I myself had seen the film 75 or 85 times before I got a chance to see it on a true 8-story screen in 4K. And that was incredibly moving. So you're not going to lose anything by seeing it here for the first time for those of you who are doing this. And if you're seeing it after seeing it big, it's a way to have a completely new experience. And we do hope to return, and we are planning that we will return to the big screen. Post-COVID, the only thing concrete we have is I just saw some announcement that the Louisiana Art and Science Museum is going to sort of do a soft opening of the film at the end of the month. I don't know how that's going to go. It's a learning experience, but beyond that, well, we don't know. We're like the rest of the world. But since we have this great special group of panelists here, I'm gonna let them introduce themselves quickly before we roll the film, so you have a sense of who these people are. And if you could just introduce yourself and say what sections of the film you might have worked on or touched. And I'm gonna start with the irreplaceable Mike Malaska.
Hi, can you all hear me? I hope.
Yes.
Yes.
Good, excellent. So my name is Mike Malaska, and I joined the film very early on, and it basically did affect my life. I just was absolutely amazed and enthralled with this work. And because of my involvement with the film, I ended up actually changing careers and going into planetary science, where I'm a huge fan of Titan exploration, which is what y'all are going to see in this movie. So please enjoy it.
So my name's Bill Eberly. I came on this project about 6 years ago, and I've spent the majority of that time working on the universe fly-through shot that we have, which contains 5 million individual galaxies. So when you get to that shot, all of those are galaxies.
So Jason is next.
Hi guys, thanks. Yeah, I'm Jason Harwell. I'm one of the co-producers of the film, and I worked on principally the Hubble image fly-through sequence, where you fly through the galaxies and nebulas, along with one of our wonderful image processors who you'll meet soon, Judy Schmidt, and several others. Was the team lead for that team, and it's been a great privilege to work with so many brilliant people who are adept in so many different fields, from astronomy all the way through rich multimedia and computer programming and image production. It's just been a fascinating journey. So thanks so much for joining tonight, and hope you enjoy.
Great. Okay, next is Ian.
Yeah, hi, I'm Ian Regan. I'm a digital artist and amateur astronomer. I'm based in Plymouth in the United Kingdom, and I'm the producer of the Titan segment for In Saturn's Rings. And I spent about 2 years working exclusively on Titan imagery, and basically trying to please Mike. And I hope I succeeded.
Mike is tough to please, but you did please him.
Let's hear it.
So next is Judy Schmidt.
Yeah, so I'm Judy Schmidt. I currently reside in Modesto. I was in New York at the time when I was working on the film, but as Jason mentioned, I worked on the Hubble imagery. Well, there wasn't really much Hubble imagery. It was mostly ground-based imagery, but anything was a nebula or a galaxy, like a standalone galaxy, not the fly-through, like that was mentioned earlier. I worked on it. I was picking stars off of the canvas, and it took a long time working with Dr. Danford's notes and picking up each star to make sure that it was in the right layer. And that's pretty much it.
Thanks, Judy. Okay, and next is Dr. Steve Danford.
Hi, I'm Steve Danford in Greensboro, North Carolina. I'm an observational astronomer, and I was working with Judy and y'all on trying to put together the fly-throughs, particularly into the galaxies. I do spectroscopy. I've taught physics and astronomy here at the University of North Carolina in Greensboro for 38 years, including the high point of my career when I got to teach Stephen.
I think what he means is the low point in his career was when he had a film student named Stephen. But yeah, he was the most fantastic professor I had of any subject ever. He's truly a special professor. And last but not least is Tim.
Hello, everyone. Shout out to any educators who are online with us this evening. I've been an educator for over 20 years, teaching earth science and astronomy. Have been with the film and the project for many years, but really think it's a spectacular piece of work, and so happy to have my name associated with it. I do want to highlight that along with the film is an educator's guide that I helped to write along with a number of other very distinguished educators. And we put together these educational lessons that are keyed to national science standards and encourage you to take a look at those and engage your students with some of the fantastic themes and images that you'll see in the next few moments.
Thanks, Tim. And I certainly also, someone who's not on our panel, but someone who's a big part, who was the project manager of that educator guide and managed the database and did a lot of production work on the film overall, Marie Van Vuuren, my partner in crime, and was certainly an important part of this. And her tolerance for 33 computers in her house, in her basement for many years. And the fact that divorce papers were not filed is a great thing. But now what I want to do is just give a little introduction to what you're going to see for those of you who haven't seen the film before. Because there's most of you probably know that this was created from 7.5 million photographs and no CGI was used. And certainly we always get questions about surely we must have done some kind of CGI. And I want to mention what CGI is because that term's thrown around, and that's computer generated images. So we weren't generating images from the computer. We did a lot of computer processing of images. In fact, ridiculous amounts of computer processing of images. And in fact, you have to do that with most space images because cameras, like when you take a picture with your regular camera, it does all the processing before it even shows you what you think is the original photograph. But spacecraft and telescopes really can't do that. They rely on manual image processors to do that. So that's what we had people doing on the film. And what I'm going to do is screen share a couple of key things from the film that you can look out for to have a better appreciation of what those are. So I'm going to share my screen. And hopefully you are seeing that. Are you seeing a galaxy?
Yes, we do.
Yes.
Okay, great. So this is towards the beginning of the famous 5 million galaxy section. And I don't know how well it will work in the live stream, but what this represents is the fact that the way we created motion was called multiplane photo animation. And this was not a new invention. This is something that Walt Disney came up with back in the days of Sleeping Beauty and Snow White. And what he did is he put multiple transparent layers of drawings to create foreground, background, and midground. And that's what we did for the film. And when you're seeing the shot in the film, which is the Galaxy ARP 273 that so many people here did so much work on, this galaxy here is our foreground object that was processed by the Galaxy team of image processors under the leadership of Jason Harwell. And then we took individual photographs of galaxies, which we made into our midground, and that was under the leadership of Bill Eberly. And if I am smart enough to switch my screen sharing program here, Zoom, can I do this? I don't know. Let's see, I think I have to stop it and start it here. So I'm gonna share another folder here. And what you're seeing now is where I spent nearly 18 months of my life. These are individual photographs of galaxies that come from the Sloan Digital Sky Survey. And I'm not going to go into the details of this other than I spent 18 months cleaning and sorting these things manually to throw out the bad data that was in there so that we could make this the midground of what was there. And then we created a background plane that was, I'm going to quickly screen share one more thing. And that, if I can find Photoshop somewhere here, Oh, Zoom is hiding Photoshop. Okay, so this looks like nothing here that you're seeing, but this is a transparent layer of the galaxies that were too far away to be part of the midground of the animation. So if I gradually reveal here, you now see something that looks black. And this is 100,000, this is a 10,000 by 10,000 pixel image. So if I zoom in, you will notice that it's full of little specks. But these are actually, each one of these a galaxy that we've placed perfectly in position. So this was our background. So when you see that 5 million galaxy shot in the film and you hear LeVar Burton say 5 million galaxies, it's 5 million individual photographs of galaxies that we processed. And I want to show you something else, because this is a section of the film that people often don't appreciate when they see it. And this is in the time-lapse section. Someone who couldn't be with us is one of the other great volunteers, Colin Legg, an astrophotographer in California, who spent nearly $100,000 of his own money to build a 5-camera computer-controlled time-lapse rig to get time-lapse footage for the film that would be high enough resolution to use. And this is a still frame from this. And what people don't realize here is that bright object there is the full moon. That's how dark this sky was. He went 600 miles from Perth to find the darkest point and the brightest time of the year. That is truly a dark sky when the full moon looks like the sun. So those are a couple things to look for. I know everybody's eager to get on with a movie. And so what's going to happen is Big and Digital is going to give a countdown. We're going to mute this live stream here. You will play the movie. Again, if you've had trouble with the instructions, be sure to look at those instructions or contact Big and Digital. You'll roll the film. We'll all watch the film individually, and then we'll come back to this live stream for our panel's presentations and answering your questions. So thank you, everybody. And I'm going to shut up. They're going to count down starting the movie, and let's do it.
So we're going to go ahead and start watching the movie as a group, so that way we can all look for the things that Stephen just pointed out to us. And so we're just going to go 5, 4, 3, 2, 1. And just like everything else, we're going to blast off and watch that movie.
Welcome back, everyone. This is Stephen Van Vuuren, director, producer.
Okay. While we're waiting for everybody to rejoin here, what I'm going to do is I'm going to swap over to my phone here, if it's going to. Okay. So can someone give me a thumbs up if you can hear me okay?
We can hear you.
Okay.
Great.
Great. Okay. So at me, and we're switching to the IMAX in the basement, which this is not the interesting part, but we just watched it here on the big screen. But where I'm going to go is to show you that we are still working on the film. And you're going to get to see in the dark hallway here. And we're going to turn on some lights. This is our exciting laundry room. But what is actually exciting is these are the computers that are still working on the full dome version of In Saturn's Rings. So I'm going to wake these monitors from their sleep, and you can get a little sneak peek at what's going on here. So I'm going to get close to a screen here. And for you computer geeks here, you can see it's using 108 gigabytes of RAM, and power usage is very high. And there's the 5 million galaxy shots. And you can see we're rendering a total of 41 frames. So that will last about 1.1 seconds on screen. To render that is going to take 269 hours on this one machine. So that is why the full dome version is taking that long. We have 1, 2, 3, 4 machines, because it takes very high-end machines to render these. So now we're switching back to me and my camera's in the way. So I'm going to go back in here and we will, hopefully everybody will be back and we can resume our Zoom call. But I thought people always think that we're done with the film. We are not done with the film. So I am going to kill this and hopefully I'm back here. Okay. Now, what we're going to do is to let our panelists kind of do a little short 2 minutes on to give you some insight into their contributions on the film. And to kick us off is going to be Mike Malaska. And bear with us, we're going to attempt to share screens and we may have a little technical glitches, but hopefully we'll get through this. And if you have questions that you want to get into the queue, go ahead and put them into the chat window, and we will compile and try to get to as many of those as we can. So take it away, Mike.
Awesome. So hopefully you guys can all see the screen that I just shared. Yes? Yep. Awesome. Okay. So
Yes.
one of the things that I want to mention is, like, in the film that we just saw, you see some really big stuff. You see, these galaxies, you see the space between the stars, you get a concept of the time, and you realize just how much of the world, the universe, is out there worthy of exploration. And you can also start asking some really big questions about, where's our place in history? How do we fit into the whole thing? And one of the things that the film touches on is, the search for life, like maybe going to Enceladus or going to Titan. My personal bent research is on looking for life, alien life on Saturn's moon Titan, not necessarily on the surface, but in the deeper part of it. And there actually is sort of a feedback with the film, because it was through the film and working with Stephen and getting this that I began to become interested in science and develop some of these ideas of the subsurface deep oceanic life on Titan. And the figure that you see here is basically the result of that effort. And this figure was the root of the Oceanus mission, which was proposed to New Frontiers 4. So it would have been a competitor for Dragonfly. And later we converted the idea behind this graphic into a NASA Astrobiology Institute that's going to be studying Titan, as well as life in other worlds. And briefly, we have all this wonderful atmosphere that you have on Titan. You have synthetic organic chemistry happening. It goes down to the surface. You saw some of the beautiful geology on Saturn's moon, the surface of the dunes of organics, the lakes, hydrocarbon lakes. But then underneath that, you have an icy crust seen here in the cross section. And down there, you actually have liquid water pockets that may be mixing with some of the organics. And that would make this perfect place where alien life could exist, because it's warm, full of organics, and under temperature and conditions and pressure that are very similar to what you see for underneath the Greenland ice sheet, where we see life here on Earth. So really studying Titan is teaching us a lot about our own habitats on our planet. And it's starting to get after some of those really big questions of what is exploration and how we fit into the whole universe. And I'm hoping that some of the work that we do and that you see in the movie that inspires you may help the next generation, or even the current generation of scientists, start getting excited and think about what we can do to start discovering more about the universe around us. And with that, I'd like to thank Stephen for the opportunity to work on this movie and pass it over to the next person. Thank you.
Well, hello everyone, and again, welcome and thank you for participating this evening. It was a real pleasure to work on this, a part of the project of this film as an educator and help write the educator guide. But one thing I'd like to highlight about the film is Stephen mentioned that many of these images we saw were not taken with a camera similar to what we all carry around in our pockets these days. Rather, the scientific data that was collected by this Cassini spacecraft is really numeric scientific data. And one of the lessons that we developed in the educator guide, and hopefully you can see this now that I'm sharing my screen, is this grid of numbers. Here we have just an array of numbers representing numeric data. And this gives us a hint of how photography works. And if we take apart that word photography, we actually understand that it's a graph about light. And here, one of the activities we can encourage students to do is to take a graph like this or an array of numbers like this and start painting them or assigning colors to the numbers. And here, if we just make all of our zero values black and gradually lighten up the greater numbers, we can turn an array of numbers into data that looks something like this. This is a 1 kilopixel image. It is about 1,000 individual data points. And when we graph that all together and we colorize it, we can visualize what is behind this. So this is just a simplified way of understanding how scientific numeric data can actually turn into an incredible image. And then, of course, we can take this one step further to an image such as this one, where we can see one of the finer pictures from the Cassini spacecraft. Rather than being a kilopixel image or 1,000 pixel image like the last one I just showed you, this is now a megapixel image or 1 million pixels. So I'd encourage you to kind of explore this, and especially for teachers and students in the bunch, we have a really fantastic educator guide. And if you can see here, I'm just kind of holding up the educator guide. And inside of that, we have lessons that are keyed to the next generation science standards. And we have lessons about impact craters on other worlds. We have lessons about dark sky observation and several other themes throughout the film. And these are geared from elementary school through high school age students. And we'd really encourage any teachers and students to go on to the In Saturn's Rings website and download some of those lessons that are freely available to anyone. So again, to all the educators out there, take advantage of this incredible resource. And as an educator myself for over 20 years, I can say a number of these lessons are ones that I've used and really are an engaging way to get students to think about the scientific data and process that data. And that's ultimately what you'll hear from some of the others on our panel this evening of how they had processed that data and made these incredible images and sequences that we just saw.
Okay, good. I'm Steve Danford, and I'm the one of the astronomers involved in this. And I want to talk a little bit about the specifics of how we turned an image that is just a flat image of, like this one of Centaurus A, that was similar to one of the images that you saw in the movie. How we turn it into a flight into this, a simulation of a flight into it, and it highlights two of the things that I think are really important about this incredible video. And one of those is the insistence that has been a part of what Stephen has said from the beginning. It's got to be real data. It's got to be images and not merely a simulation. And the second thing is the difficulty of trying to do that. And so I want to talk about that. You want to build planes, geometric planes, starting with a plane that would include only the stars in this image that are right near the Earth, right near our solar system, and then additional planes as you move further and further from the Earth. And then by displaying sequence of those planes, beginning with the near and going to the more distant, you get a sense that you're actually flying into the galaxy or flying near the galaxy. Now, you can't, it turns out, there are so many unknowns in this that you can't really do it with strict adherence to mathematical laws. You've got to do a little bit of guesswork. So what we did was we tried to pick out the closest stars in an image like this, measure their distances, find out what their distances were, and then find the next.
Just to interrupt you for a second, but we're not seeing your screen.
Oh, the screen's not there. Okay, don't know what to do. I'm looking at it real well.
Do you see there's at the bottom? There's a share screen.
Yeah, I clicked on that. Yeah.
And then when you click that, it should give you the windows on your computer, and then you choose the window that you want to share. So you can just go ahead, Steve.
Okay. So the ways we measure the distances is to use stellar parallax. Anybody able to see any of this at all? Nothing?
Yes, we can see it.
A blue screen with the word stellar parallax?
No, white screen with the words increasing distance.
Okay. That's something else. Okay. Don't know what that would be.
No, it looks like the right image to me.
Okay, blue screen with stellar parallax is what I'm wanting to show. Anyway, we calculate the distance to a nearby star just by watching it 6 months apart. A nearby star will appear to move back and forth a fairly large distance. The further the star, the smaller the distance. So we take measurements of stars taken 6 months apart and build the planes out of that. Now we've had about 200 years for astronomers to try to build up their expertise to do that, but only beginning in the late 1980s did we get to be fairly good at it with satellites. And when we look at a typical galaxy image like of the type that we are incorporating, we only saw, say this is six years ago when we were doing this work, we might only see a handful of stars that had known distances, but we could estimate what a group that would be slightly further would look like and pick those stars out. Then we could imagine that we reach the galaxy and we fly through it, and there were fairly decent measurements for another dozen or so galaxies that are clearly behind the galaxy. So doing this for nearby stars within our own Milky Way, reaching a galaxy like one that was about 12 million light years away, a typical image from what we saw in the movie, and then flying through that galaxy and looking at the faint little specks that are galaxies another 100 or many hundreds of light years, of millions of light years behind the one we just visited. Okay, so let me stop with that. Passing it on to Jason.
Okay, thanks. Let me go ahead and share the screen here again too. And just let me know you guys can all see this.
Yes, we
Okay.
can.
So here's one of the images that Dr. Danford would provide for us. And this is a photo inverse in black and white of the actual galaxy image, which I'll show you here in a few seconds. And he went and annotated, he and his students, I believe, went and annotated the stars for us in increasing, or in order of increasing distance. So then we knew how to go into Photoshop and hand remove those digitally. And I'll show you the process for that, how we went and separated them into plates. So we went in and separated them into plates based on the camera plane, and a stack of the stars in the foreground, midground, and background were extracted from that data to produce what I'm about to show you. So what Tim showed you earlier looks like this when you get into Photoshop. We're zoomed into the individual pixels now, and we can gradually start zooming out. and you'll see that's the image. So the photo negative is marked up, and then we get the actual image, and then we adjust that and break it up into layers based on the paint settings in Photoshop. And we use actual paint tools in Photoshop that Judy will get into some more detail with for you. And when we get this all set up, once it's all done, we've removed all the background stars. They're separated under their own plates. And now they can be moved around manually, and a camera can be flown through them. And I'll show you a little bit about, it's similar to that kind of effect, but you see it move back and forth closer and further away because we have 3 dimensions to work with in the editing suite. So once this is all done, we have the painted image, and it looks almost indistinguishable from the original image. And that's it. So with that, Judy's going to get into the details of some of her masterful processing work and some of the techniques she used to actually achieve this on some of the more difficult images like the nebula and gas clouds.
Oh, okay. Thank you, Jason. Let me share my screen now. Okay. So where to actually begin? Well, I said earlier that I mostly work with Hubble data, but what I was working with for the film ended up mostly being ground-based, like from ESO, and that's the European Southern Observatory. So it'd be like this, and picking those stars up off of the screen is not easy, but luckily space is black. And that kind of helps because certain layer modes in Photoshop, you can kind of ignore the black. So you can see that outline there. But if you change the layer mode to like screen, you need a background. This is a transparent. I use purple instead of a grid for transparent. Nope, don't want that. Anyway, it would end up more like that on the film, and it would be able to go in front of other things without showing that hard outline, because how to explain it? It's all math, and if you have black, that means 0, so a 0 would add nothing to the image. And yeah. Okay, we can revert this. That would be Dr. Danford's markups. And then each one of those, like there's a 0 or a 2 or a 1. I went right up close to it and I cut out each individual one, and you have to actually take out each foreground star from that middle star or background star, because you can see background through the middle until you get all of them removed. And you know, does that make sense? Like, yeah. So that would be the background, and there it would be without them removed, without them in there. And it's pretty hard to do. You can sort of, if you get really close to it, you can still see them, like sort of outlines. But I did my best. Anyway, this is what I think is really cool, being able to see the nebula without all those stars. Another thing I wanted to share, though, is before any of this ever even makes it to us, someone else, like say if you had a Hubble data or an ESO picture, like before it even turns into color, it doesn't look like this when it comes from the telescope. You get, say you get the blue channel and the green channel and the red channel, and you have to combine them all together to make a color image. And on top of that, these moons and stuff, they're actually moving around, and it is kind of a pain to get them lined up. Because if they're not lined up, then they kind of, like that one's just green. Where's the other piece of it? I don't know. There it is. Yeah. And there's all sorts of things like cosmic rays and stuff that you have to get rid of before it starts looking pretty. But that's what I do. I make pretty pictures. I wish I was better at presenting things, but I'm not, you know, much of an educator. I'm more of an artist, so it's a wonder I even came out here to join you guys today. And I will pass it on to the next person. I'm not sure who's next, but I'm done. Thank you.
Thanks, Judy. And yeah, much of the beautiful stuff in the film is from Judy, but we're going to go on to Ian next.
Yes, that was very good, Judy. I'm in awe of your skill. And my role in the film, I'm based in Plymouth, in the United Kingdom. I'm a digital artist. Hopefully one day I'll be as good as Judy. But in the meantime, I'm the producer for the Titan segment of the film. And Mike's already extolled the virtues of exploring Titan. It is essentially the most Earth-like object in the solar system apart from Earth itself. But it's not terribly easy to explore, and if you bear with me, you're about to see why. Here we go. This is a natural color composite photograph of Titan as taken by the Cassini spacecraft. This is pretty much how an astronaut of the future would see Titan looking out of the porthole of their spacecraft. They would just see this big orange, yellowish ball. Looks kind of dull, but that's down to the smog in the atmosphere, this hydrocarbon smog that obscures the surface. Now, when Cassini went to Saturn in 2004, it was equipped with various instruments that could pierce this haze and show us the surface. And what it discovered was quite amazing by anyone's standards. And so for the film, we decided we were going to have a virtual flyover of some of the particularly interesting features of Titan, ones that we could compare to features here on Earth, such as the dunes, the lakes, the craters, so on. To do that, we used two data sets. The first data set was the radar data, which was collected using Cassini's high gain antenna, which is the big white thing on top. And it returned images like this. Now, these images are fantastic. This is a cropped example. They're very long and spindly, as you probably could see in the film. They're very sharp, very detailed, but also very noisy. And if I zoom in, you can see here, this is a lake near the South Pole. You can see that the data is very sharp in places. You can see what looks here like a river channel that's draining into this lake. And you can see that there are various seams, the quality of the image changes from one part to the next. And so my job was to restore this and get rid of those differences to make it look as good as possible. And I restored several of these waves with the help of a volunteer from Poland, and I'll give him a name check. His name is Jacek Bobowick, and I hope he's watching. And this was the result of the restoration, which I have to emphasize, I didn't use the clone tool. There was no inventing data or anything like that. This is a cleaned up radar image of Titan. It's actually several radar images overlain and carefully aligned. And if I zoom in, you can see, again, the river channel draining into the lake. This wonderful lake. You can almost imagine having a nice houseboat on there, although it would be a bit chilly. If you look very closely here, you can see what the cursor is. There are actually shore line marks there, marks where the liquid has made marks on the land. So it's so similar to Earth. There's nowhere else in the solar system like this. And there's another lake there. And now, as good as this data is, the radar data doesn't have a sufficient resolution for a big screen. So you're going to show this on an IMAX screen or a full dome screen. These images just aren't big enough. So we needed a context data set to act as a backdrop. And we resorted to Cassini's conventional camera, which returned low to medium resolution images in the infrared of Titan's surface. And here is one such example. This is a view of the Saturn hemisphere of Titan. Essentially, this is the side of Titan that faces Saturn. So if there are any microbes in Saturn's atmosphere, this is the view that they would see if they could look through the haze. But if you took hundreds of these images, you can make up a global mosaic of Titan. And the US Geological Survey did exactly that in 2013. And this is what they produced. You can see that they didn't get around to doing the North and the South Pole, which are the black strips. But my first job in restoring this was to tidy up all these seams and these jagged areas here. And it was like working on a jigsaw puzzle that's already been assembled, but where the individual pieces needed adjustments being made to their brightness and contrast. And it was quite painstaking. I think this took about 6 months. And once I'd finished that, and then I constructed the North and South Pole completely from scratch using archived Cassini data. And this is the result. And there you can see from the North Pole down to the South Pole. This is an equatorial projection, and you can see the equatorial regions with the vast dune fields. You can see the mountains of Eberly there. Come down, and you can see that lake that we saw in the previous radar image there. So, I mean, this took me about a year to complete. It was a real labor of love, and it's not as scientifically accurate as I would like, but I think it's pretty good. It's pretty good. You may notice over my shoulder, I have a poster on my wall with the final product. Another projection, this is a polar projection. This shows the US Geological Survey mosaic before I'd actually constructed the poles. It's the North Pole on the left and the South Pole on the right. And that's when I was finished. And here on the left, you can see the extensive system of lakes and seas at Titan's North Pole. And in fact, the one I'm zooming into now is the one that was shown quite prominently during the film. And that pretty much concludes my contribution to the film. I also did the mosaic of Saturn that you see right at the end of the film, the very last mosaic that the spacecraft took. And I'd completely forgotten that I did that and that it was even in the film, because I haven't seen the film until now. So this is a new experience even for us, some of us. So I'd just like to thank Stephen for everything and everyone else on the panel. And at this point, I've probably overrun my allotted time, so I'll pass it on to Bill. Take it away, Bill.
All right. So hi, everyone. I'm Bill Eberly. Just sharing here. So I came onto this project I'm a software engineer. I've never worked anything having to do with film or space images before. I answered a call when they were looking for developers, and I got handed what I did not know was going to be a very complicated part of the film, which was the 5 million galaxy shot that you saw, which was intended to add some context to those wonderful pictures that Judy and Jason showed you of galaxy and nebula. We don't want to just show those, we really want to show where they are in the context of the whole universe. So to accomplish that, we used images from the Sloan Digital Sky Survey. So right here is one of the 400,000, I believe, images that Sloan produced. And me and my team, we wrote some software that downloaded all these images, and we tried to find all of the galaxies in them. There we go. Since we want to fly through the universe, we don't just want this whole photo. We only want the galaxies, and then we need to be able to place them in 3D space. So our software used some of the data files that were also provided, which told us, you know, here's where we think there's a galaxy, here's where the star. We look for the galaxies throughout the stars, and we tag them with where they actually are in the sky. This produced the 5 million galaxies that are mentioned in the film. And here's just a very, very short, a very small subsection of these. You can see we've got some very large ones. We've got spiral galaxies. If you look close, you'll even see a couple stars. I believe this actually comes before Stephen spent a very long time cleaning this data up. And here's some of the even smaller ones. So we had 5 million of these, and we had to cram this all into Adobe After Effects. After Effects does not like 5 million of anything, it barely likes 5,000 of anything. I think the process of getting everything into After Effects took more time than actually getting these galaxies generated here. Once we actually had it in there, we had to render it all out. Stephen showed you the renders he's doing on the full dome version right now. The flat screen version was a little less intensive, so we were lucky to have a lot of volunteers. I believe we had about 60 machines rendering all together, and we were able to finish that render in about 6 months with that spread out. But that was a total of 7 combined years of render time. So that would have taken one very powerful computer 7 years, and we were able to split it up. So thanks to any of the volunteers who might be here who helped with that render. Here's one of the background tiles that Stephen showed earlier. So about 4 out of the 5 million galaxies ended up going into those background tiles. I believe they were 10,000 by 10,000 pixels wide, and there were 272 of them total, which comes out to something like 27 gigapixels worth of just background information. Those aren't the ones that you're flying through. That's just behind us. We've got 27 gigapixels. And so the final product that you saw in the film looks something like this. Every single speck of light, every single dot that you see in this photo is its own galaxy with hundreds of billions of stars, planets, nebula. The amount of things that are in this photo consistently blows my mind every time I look in it. This is the full 4K version. If we zoom in here, you can see just how detailed this gets. Like I said, every single dot in here is a galaxy. So that was my contribution to the film. Was all 5 million of those galaxies. I'll hand it back to Stephen here.
Thanks, Bill. And it's too bad we're not all in person, because everybody here deserves a round of applause for their incredible work and gifts. And believe it or not, this is an incredibly simplified explanation. I do want to give a plug to the website, and I will put that in the chat, because Jason, Bill, and Ian, and Colin, who did the time-lapse photography, have done some really, if you'd like to learn more and see a lot more detail of their work, or you wanting to do some educational outreach of your own from the film, they've got detailed breakdowns of the sections that they work down that really drills into all of this, where you can see specific examples. And now we're available to answer any questions. So if you have questions, please put them in the chat. And if you want to direct them to a particular person, direct them, mention the person that you want to ask a question for. And if you just want to ask it in general, that's fine also. And we did have a couple of questions earlier. So I'm going to, while the questions are coming in, I'm going to pull those questions up right now.
Do you want me to get started, Stephen?
Oh, yeah, go ahead, Sincere.
All right, so the first question we have are, what are some of the film and director's influences you have had leading up to making In Saturn's Rings? And were any of them involved in space films?
Okay, I'm guessing that's a question for me. Yeah, absolutely. And I'm just going to focus on one, and that's Stanley Kubrick. And like many filmmakers, I got interested in making films from seeing 2001: A Space Odyssey. And there's a deep connection between this film and Stanley Kubrick. For those of you who are not Kubrick buffs, the 2001, he wanted to set it at Saturn. He felt that setting suited the story of the film best. But in 1967, when they were starting visual effects work on the film, the imagery that was available of Saturn was extremely poor, but they still worked on it for a while. And finally, Stanley said, no, we're gonna go with our second choice, which is Jupiter. So one of the reasons that I wanted to make this film with real images was kind of as homage to Kubrick, and something that I felt he would have felt good about. Of course, he died in late 99 or 2000 after finishing Eyes Wide Shut, before we ever got started on this. But I wanted, if you noticed in the film, there's a quote from Stanley Kubrick in there, and we needed to get permission from that. So I contacted his wife, Christiana, and his executive producer, Jan Harwell, and they know about In Saturn's Rings, and they gave us the approval of the estate. And when it screens in the UK, they will attend. So this is why, Tina, you got to get us a screening in the UK, not only so Ian can see it in person, but so we can have it there for them. So, and he was a big influence in the film and letting the images speak for themselves, and not overburdening it with too much narration. We love LeVar Burton, but the narration is only about 1,100 words, so that you can it's a music-driven film with images. So that definitely is also from his philosophy of making films. But great question.
Thank you. We have another question here. Is there one place in the solar system, planet, moon, etc., that has always captured your thoughts and you would like to see more explored more?
Let's have some other people jump in and answer that. Let's go with Mike.
Absolutely. So yeah, me personally, I would love to go about 10 kilometers down in the ice shell of Titan. And that's exactly the sort of stuff that we're trying to plan for. But that's maybe, oh gosh, I won't even put a name on it, probably 20 to 30 years out. That'll be a really complicated mission to do. But also some of the beautiful imagery and planning of the Dragonfly or similar missions might be good. Some of the detailed labyrinths, which I don't think we saw in the movie itself, but I think we might have skimmed over a few of them in some of the pre-cuts. Those would be fantastic things to see as well.
Wonderful.
Does anyone else want to answer that question? Like,
that's a good one
on the team?
Yeah, I would love to see us visit Triton again. I think Triton is absolutely amazing. I mean, Pluto rightly gets all the headlines, but I think Triton, with its the plumes and possibly seeing changes since we've been there via Voyager back in 1989. I would vote for Triton personally. I don't think Mike's very happy I didn't say Titan, but I had to go for a different name.
Triton's all good too.
Can I jump in here too? This is Steve. Let's not forget Mars. I love the idea of Titan and exploring Enceladus both. But remember, Mars, as difficult as it is to go to Mars, it's a lot tougher to go to the Jovian moons. And we're in the middle of some really exciting exploration with the new Perseverance rover and what we're going to be learning in the next year or so. So let's not forget Mars. It's a very exciting place.
I'd just like to chime in for Europa. Much like Mike's interested in on Titan, it's got a surface of ice, and there could be liquid water beneath that, and there certainly could be extraterrestrial life there. So I'm very optimistic we'll see some amazing things if we bore on Europa.
Well, I'm looking forward to our floating cities that we're going to build on Venus and find all that life on Venus. It's not really life.
Well, Judy, I saw this really great 1950s sci-fi film about Venus about 3 months ago that very strongly campaigned for some really fun life on Venus. So I'm hoping it's deeply scientifically accurate, even though it was an Italian-American co-production with a very low budget. But I'll just chime in that I think our answer here is we need to go everywhere, all the time. And it's not inconceivable if all the nations of Earth spent their money just a little bit differently, we could certainly have a lot more missions than we do. But I would like to put in votes for Cassini style long-term orbiters at Neptune and Uranus. I think just like the stunning surprises that Cassini gave us about Saturn and things that we just didn't expect to find at all, I think, multi-year missions orbiting those two magnificent giants and moons would blow our minds.
Definitely. We have a couple of questions that have come in. Let's see. Did you learn a lot while making the movie? I think that would probably apply to all of you.
Yeah, so why don't we go, we haven't, let's just hear from everybody. Let's start with Bill.
Sure. And one thing I certainly learned is how big of a number 5 million is. I think it's a small enough number that it gets thrown, something like that size gets thrown around a lot. But until you go and look at 5 million of something, you don't really get the scale of just how big of a number that is. I mean, I'm trying to pull it up right now. I'm not sure if I'll be able to quick enough, but I can pull open a file on my computer with 5 million galaxies on it and just scroll through them endlessly. And other than seeing them all at once in the film, I don't think I've ever seen them all, individually. I know Stephen has, but I sure haven't. And knowing that those 5 million galaxies each have, 100, 200 billion, 300 billion stars in them each. I think I did the math on it once, and the number of stars in that many galaxies has like 18 zeros after it. So 5 million galaxies get you, one with 18 zeros after its stars gets you who knows how many more planets. Just really being able to realize the scale of the universe from this project has really been a big deal for me.
I'll chime in since mine relates to what Bill said. I will put in the chat a link to a TED talk I did about processing those galaxies. because I did go through all of them, and that's kind of my learning experience. But I'll mention something else that I learned very kind of terrestrial is, you know, social media and the internet gets a lot of negative vibes, and it certainly has a lot of problems. But this is a film that entirely came to be based on the ability of the internet to connect people of like interests. And I don't think that value can be understated, because truly, if I'd wanted to do this film in 1995, it couldn't have happened, because in the world and people I've known, I could have never connected with the people that places like Unmanned Spaceflight Forum, where I met Mike and Ian from, that got this thing started. These type of communities that connect like minds, I learned the power of that. And if we could only find more ways to harness this for good, to connect people together, to do things that are otherwise impossible. And this film is just, to me, a tiny example of something that we haven't yet tapped into as a resource. You know, we've organized protests and we've done some things, but as far as building things, I don't think we've really tapped into what we can do. Anyone else about what they learned?
I think what I would like to say on the subject is, I think what I've learned, and I kind of knew it already before I got involved in the project, but it's the difference between CGI and real photography. I've noticed over the years that watching various documentaries, fantastically produced documentaries for people like Brian Cox, Dr. Brian Cox, and they use so much CGI, and they'll talk about Enceladus, and they'll say, look at this, and then they'll show this fantastically rendered CGI video of Enceladus's plumes. And it's fantastic. And then they'll show a real photograph, and it's like thrown in as an afterthought. It's like, oh yeah, we've got this photograph, we'll show you after this sequence. And it's always irritated me, because to me, the beauty about space exploration is actually seeing something that's real, not something that's contrived or artificial, but seeing something that gives you that a sort of visceral reaction as a human being. And that was always how I felt, but it wasn't until this project that I realized how important it really is. And that's why I was very careful when I was restoring the radar and the photo mosaic to not use the clone tool, to preserve as much real data as possible. So, you know, if there was something nasty in the corner, I would try and find some data that I could cover it with. But in the end, it was about the purity of the vision of just using real data. What you see is real. It's not been made up. It's not something in Blender or something. And so that's the takeaway message that that I have.
I'd add to that. Those of us who work around telescopes, I'll bet a number of you probably have your own telescopes, see this kind of thing every day. People are desperate to look through a telescope to look at the sky, and they really don't want to see a television image, for example, of it. They want to go to an eyepiece and actually look through the telescope. There's a visceral thing to that Ian was just describing very nicely.
Yeah, I think, I mean, I love you guys for those answers, and that really is about finding like minds. There was a number of CGI artists that emailed me over the course of production of the film when we would be talking about how long it was taking us to do things. And they were like, well, why don't you just use CGI? But there's actually a real practical reason that CGI doesn't work all that well for space objects, because I actually am a filmmaker and I work in film. So if you want to make a CGI model of, say, you know, Ian talked about Enceladus. Well, to do a really good model, like when they're doing a really good model of, say, you know, an Avengers hero that's a human being, and you've got to model the skin and the hair and the eyeballs, well, you have to put in the physical properties, the scientific understanding of the actual optical light chemistry interactions that are happening. But as someone like Mike will attest, if you get 20 scientists into a room who study Enceladus and ask them what their best theories are for the chemical and refractive processes on Enceladus, you'll probably get 20 different answers. So it doesn't leave a CGI artist just has to make it up and guess. And right now, the spacecraft and the images we give much better answers. And I know this for a fact because one of the CGI artists that contacted me said, well, I'm going to send you a better Saturn image than Cassini can do. So about 3 months later, he sent me something, and it was plastic is the best way to describe it. It moved me unemotionally, not at all. So yeah, I think that this is a great question. Jason, what did you learn from working on the film?
Oh my gosh. For me, it really had to be the science. Just from everything from what Dr. Danford was talking about how they calculate stellar distances by parallax, and I suppose the trigonometry that's involved in that, to the hydrocarbons on the surface of Titan. This is why I got into making this type of media. And I encourage anybody out there who wants to learn about science, go and start making something about the topic you want to learn. And you'll find that you're constantly blown away. And you know, this is why I got into this, and this is why I wanted to help bring it to life. So for me, it was really all about the fantastic, real knowledge that's out there that anyone can access if they just want to, you know, wade into it.
Okay, do we have any other questions that people want to ask?
So I have another one from the ones that were sent before. Would anybody be willing to go on a one-way trip to Mars?
Would I, maybe a one-way trip to Mars? I know the right answer is no, but I would have a hard time saying no to that. And if it was a one-way trip to Saturn, yes. I would do that in a heartbeat, especially if I were allowed to take a camera.
I would go at age 90.
I was just about to say 80, but I'll take 90 if I make it that far.
Here's another question. Does anyone have any plans on working on other projects in the future? And is there any new missions you would like to work on?
This will be, people have asked me about a sequel to this film, but since I'm still working on rendering the full dome, I'll end up with about 16, 17 years of production work on In Saturn's Rings. That will have to be someone else. Maybe it's one of these guys right here will decide to take the next big batch of mission data and make the next film. They certainly would be capable of doing it. But I'm going back to my little life making just little, I like sci-fi films, so I'm going to go back to making just regular old science fiction films.
Anybody else willing to throw out there that you might be willing to take up the next torch?
I wouldn't say that I would be interested in making a full film for the large screen, but one ambition I do have is to restore and put together as many of the Voyager approach movies of the giant planets that it took, and put them together and restore them and make them as good as they can be. I've already done Voyager 1 at Jupiter and Voyager 2 at Jupiter. In fact, a small segment of the Voyager 1 film was used in this film. That's my kind of thing, is going back, looking at old data and trying to clean it up and make it look pretty, I suppose.
Like it.
So personally,
I'll put in a quick plug for Jason, since you can rewatch. I'm sorry, for Ian. So because you can rewatch the film, you have a 24-hour window. If you go back and during when we're going the section of the film where we're going towards Cassini, we go by Jupiter. If you look at, you may not notice that Jupiter appears to be rotating in that shot, unlike the other planets, and that's because that is one of Ian's little sections of multiple exposures of Jupiter. So it's like stop motion Jupiter, but done very smoothly. Of course, on the giant screen, you can see that easily, but you may need to go back and revisit that section so you can get an idea of what he's talking about. That's very beautiful stuff that he's doing. Sorry to interrupt. Go ahead.
You're fine. Thanks. I'm glad we can all go back and watch it. In all the photos that all of you worked with, did you see anything that appeared to be extraterrestrial? Anything flying around?
Yes, but then I realized it was a cat paw print on my monitor and I wiped it off.
You know, nothing would make me happier than, because I love sci-fi, I love aliens. You give me a cheesy alien invasion movie, especially from 1950, I am there. Nothing would make me more excited. And I honestly hoped, it was like, well, if anybody's gonna find anything, it's gonna be one of us pouring through all these images, because between us, and especially Bill and I on those 5 million galaxies, we looked at images that the SDS team had never looked at before, that no human eyes had ever looked at before. But we found zero. The only thing I will say is I found it fascinating in those 5 million galaxies that so many spiral galaxies, when they're viewed kind of at a certain angle, make a perfect flying saucer shape that's used in those 50 sci-fi movies. But I guess that's coincidence, but it is an interesting coincidence. But no, never anything remotely as badly as I would have loved to have seen something, but we didn't see it.
During our work on that 5 million galaxy shot, I thought that it wasn't aliens, but I did for a while think that we had possibly discovered one of the farthest ever known galaxies to ever be imaged. And turns out I'm just very bad at math, and it's much closer than I thought.
I would say actually yes, but not in the conventional sense, more along the lines of what Mike might want to talk about a little bit more. I think that lakes of liquid hydrocarbon is very much seeing something that indicates potential for extraterrestrial life. So I can't say that I saw aliens, but we certainly might have seen the habitat for alien microbes.
So I'll also add that we did see a lot of weird stuff, landforms around some of the lakes. And one of the ones that has just come out fairly recently is a lot of the smaller lakes, not the big, huge ones, but the smaller ones actually have huge rims around them, up to 100 meters high. And we're having a very hard time explaining how that can actually happen. So there is some really weird stuff going on down there just geologically that is giving us like really fun mysteries and potential for further exploration to try to figure out what it is.
Are they calderas, Mike, do you think?
That was one of the ideas. I don't think that fits. Personally, no. I think it's actually, I believe some of the ideas, and they're actually some of the ones that I've kind of come up with that have made it out in print, is that it's actually, it hardened around the rim, and then a lot of the landscape just kind of blew away, and then you left with the hardened part kind of upstanding like a rim. But that has its own little issues as well. So there's a bunch of us like sitting there trying to figure it out. And I remember the scientific paper that it came out from Sam Birch had a great sentence. It's like, you know, whatever scientists' evolutionary theories we have about how these lakes formed, they will be constrained by the formation of these rims. Basically, like, we have no idea how this stuff happened. So it's really fun to start speculating what could have gone on. I don't think it's aliens though, but yeah, it's cool.
Certainly is.
I have another question. I'm going to go back to some of the ones that were submitted on the website. And here's one I think everybody can also participate in. And that's, is there one image or favorite that stands out from the many that Cassini took? So what's everybody's favorite? What really spoke to you?
I mean, I'll have to say the one that, I mean, it's really hard to pick a favorite. So I'm going to have to go with two, but certainly the two backlit mosaics that were made, that of course, the one that's featured in the film where we see the planets. But the image that excited me most was the first one that the raw image that came down of Enceladus, where we saw the icy jets coming from the surface. That was a total shock, a total surprise. And it's still, to me, one of the most exciting images, that space images I've ever seen.
I find this really interesting that as soon as you asked the question, I thought of two images right away. And they were also the backlit Saturn and the plumes from Enceladus. And we hadn't planned this ahead of time, but the, you know, as someone with a geology background, the fact that we could see active geology, these geyser plumes erupting out of Enceladus, is just amazingly spectacular. Because, you know, as Mike was just alluding to, we have these dams or levees, if you will, around the lakes, which is terribly interesting. But to actually see something changing in real time as we fly by, and the fact that a little bit later on in the mission, Cassini was able to fly through some of those plumes and sample the chemistry of the ice plumes coming out of Enceladus was spectacular. And then that image of Earth in Saturn's rings is just one of those spectacular ones of putting our place in the universe.
Anyone else?
Yes, I have a favorite image from Cassini, and can I screen share it?
Absolutely.
Okay. That is a picture of Daphnis, little tiny moon in between two pieces of Saturn's rings. And it is like gravitationally just pulling these ring particles and making these waves. And if you look at this image, I got it from APOD, but if you can look really close to it, you can actually see all these details in the rings, and like you can almost make out those ring particles. That's in one of the things that a lot of artists have tried to envision is, what do these rings actually look like if you could actually get close? Like if you were in a ship and you were hovering over them, like what would they actually look like? And this is one of the images that's about as close as you can get. We still don't know. I guess, you know, the theory is they're kind of like stacks of rocky ice chunks that kind of form long strands. But so far we can't see it. But this is a really good, amazing image. Thanks.
Anyone else?
I just want to say we could probably do this for a very long time, but we've got some people like Ian in the UK who have been up forever and ever, and we must appreciate it. So we're going to wrap this up. I want to have a little toast here. I just want to toast everybody who's participated on this panel and all our donors and volunteers that are present and not present that made this film possible. And of course, thanks to Big and Digital for distributing the film and for making the streaming possible. And I can't thank all of you enough. And we are going to repeat this again in a few days on Saturday. But I think it was very special again to be able to do this on the 3rd anniversary of the Cassini grand finale, a very special night. And I can't thank you guys enough. So please feel free to rewatch the film in the audience out there, and thank you for joining us. And let's all stay safe and hope to see each other when watch the film in person in the theater. So thank you all so much, and we'll let Big and Digital sign us off here.
Thank you so much, Stephen, and everyone who presented tonight. And Sensei, thank you for running our event tonight, but I think it went really well. And thank you to everyone who joined us. So yeah, join us again Saturday if you can, right? Thank you, everyone.
Thanks, everybody. Thanks so much.
Love you guys.
Bye, Stephen.
Thank you.
Bye, guys.
Thank you very
Bye.
much. It was awesome. I learned a lot. It was really cool.
Thanks so much.
Yes.